All right. Okay, so as he said, this is opaque structures and other Yerbas, but this time at top speed. So this is me. He already introduced me. Let's move on. I'm here because of Adrol. I forgot that. I'm here because Adrol helped me get here, and they also are hiring, or we are hiring. So if you want to work with me and these two fellows over there, you can talk to us, and we can put you in contact with the company. It's a very interesting and challenging job. Okay, today I'm going to talk about Erlang, but I'm going to talk about a particular, very small thing in Erlang, which is types. I'm not talking about concurrency, fault tolerance, nothing like that. Just pure sequential Erlang as a functional language, and I will talk about types. I will talk a little bit about modules and functions, and the talk will derive to specs, but not too much. So if you know what the type is, you are fine. You don't need to know Erlang. That's it. It's very, very beginner's talk. In Erlang, okay, and to introduce this thing, what I will do is I will talk about how to write a program when you have to define your own types, right? In Erlang is dynamically typed, but it's also closed, right? You don't define new classes or structures like that. You have the basics, which are integers, strings, lists, tuples, etc., right? But when you are writing software and you're modeling the real world, you generally want to model stuff that has much more properties than just a number or structures like that. So you have different alternatives to model things in your problem domain. I will do the bad thing, and I will compare the worst possible one with the one that I'm recommending, so you see how good the thing that I'm recommending is. But in any case, I promise you that even if you choose the one that's closest, it's still better. So the alternatives are the alternatives that I will compare are those two. I'm basically comparing a program where you represent stuff using only basic types against a program where you define your types as types and you put them in proper modules, etc., right? As you can see, the list of basic types, the list of what I put in basic types as a way of representing entities grew over time. These are in that order for a reason. Originally, with just Erlang, you were forced to use lists and tuples or numbers, etc. You can group them in tuples or lists or whatever, but you didn't have a proper way of defining your own types. Eventually, the developers realized that that was too poor, right? So they started using a convention, tagged tuples, which are tuples where the first element is an atom that defines what you're looking at, right? And that convention became popular and turned up into records. Records are tagged tuples in runtime, but syntactic sugar, so you can use that more efficiently. And the time went on, and eventually we had maps where even in runtime, you know the names of the properties of the stuff that you're working on. But still so, I think there is even a better, it's orthogonal thing to this, but it's a better way of structuring the code, and I will show you. So let's move on to an example. This is an ancient Chinese game, as far as I know. It's called Neem. And I used to play this in the blackboard of my elementary school. The game, I will show you super fast, but the game is a two-player game. Each one crosses sticks on the board in the same row, and the one that crosses the last one loses. Something like this. And poor pink guy lost the game, right? Super fast. If you didn't understand what happened, just Google it. In the long talk, I explained, but now moving on. Okay, so we're gonna model that thing, right? But the first thing I will set up here is that since I'm not talking about concurrency, distribution, anything else, I will just model a snapshot of this system, of something that lets you play Neem, okay? And so the first task is to recognize the entities that we have in this problem domain. We can spend an entire, the simpler the problem, the more talk we can have until we define the entities. Just go with me. I found 4 different entities here. One is a game. I added the date there just to name it. Then you have 2 players. One of them is the one playing now, and the other is the other. And they play over a board, all right? So the board is basically a group of rows. Each row has sticks. Some of them are crossed. Some of them are not crossed. Done. Player is easy. It's just the name. We don't need more information. Maybe in the real life you do, but over here it's just the name. Doesn't matter. And the game is just the set of all those properties, right? It has the board and the 2 players with one particular feature that the game is the only one that knows which one is the current player and which one is the next one, right? So when you move, those are switched. That's the idea, all right? OK, let's model this with basic types. As I said, for the players, I only care about the name, so strings. Right? I could use binaries if you want, but it's the same. And for the board, I choose to model a board with 5 rows, which is a tuple. And the rows, I choose to use a list. I could have chosen the, tuples there. You will see why the list in a second. And basically, the game, as I said, is all of those things together, right? The current player, the next one, and the board. It's a tuple with 3 elements. And the knowledge of which one of these elements is what is in your head. It's nowhere in the code, right? But you know, because you wrote the program, the first one is the current player, the next one is a second element in the tuple, you're fine. Right? OK, let's write some code. So you have the main function of a program is to cross a stick, cross a group of sticks. I used an auxiliary function in the middle, but you can trust me, it changes once to zeros, right? Fine? OK, so first, we decompose the game in its 3 constituent elements, the current player, the next one, and the board. We find the row where we want to cross the sticks. We cross the sticks, put the row in, and the last statement there that seems trivial is the one that changes the current player with the next one. So moving on to the next turn, you use the result of this function, right? And you can call this function time and time again until the game is done. Of course, we are not checking if you're not cheating, if it's all that part is outside of this. But everything else, all the other functions that check if somebody won, that start the game, etc., use the same kind of structure here. They decompose the game, do stuff, compose the game again, all right? Or extract properties and just return them. All right. So what are the issues with this approach? Let's say the first one is that what happens is something changes. And of course, our systems are eternal. No, nothing changed. That's fine. But let's say something changes. And something changes like this. Now the game, which currently had 3 properties, will have 4 properties, right? It will have a name. First, you say, well, it's easy. It's a tuple with 3 elements. I put the 4th element there. Done. What part of your code do you need to change? Right? You have to find everywhere where you're using a game. You may be super detail-oriented and have consistent naming of variables and whatnot, but you still have to check everywhere where you find a tuple with 3 elements. That tuple with 3 elements is actually a game and not maybe module function arguments for saying anything, right? And that means that you cannot. The only way to be sure if you changed every single place where this thing happened, or every place that you needed to change, is to traverse all your code. Not good. Then we have amazing errors. Erlang is famous for that. Our error descriptions are top-notch. Nothing to envy Elm or any other language. But let's say we have this one, right? Bad match, and that's an empty string. So it's a player, right? Well, no. It might be an empty row, because rows are lists, and so is this. And you have no way to say, because it's just that. You might have the stack trace, but the stack trace may point you to the function where the problem is. And as you saw the function before, the function modifies rows, players, games, everything. So terrible for debugging. And then let's think of this as a library. Because in this example, it's not that clear, right? You're just using this thing as a software. But many times, you're producing libraries for other people to consume. And if you are exposing these kind of things, what prevents them from sending you a board with 4 rows or 6? Or a row with the same elements as the previous one, or players that instead of strings are binaries, or whatever, right? Unless you document all that stuff, they will never know. And if you document the stuff without using any other thing than the basic types, the documentation is text. You are explaining yourself, but it's not verifiable, and it's not in the code, right? So it gets outdated, and irrelevant, etc., all those problems. OK, let's first tackle this issue. And let's add some documentation in code. You know what spec is? Who doesn't know? Good. So you add a spec, right? Amazing. You added 9 lines to every function you have in the code. And now you are super productive because you 9x fired your code. Your boss is happy. But actually, right? And you have to be consistent with the naming, and not good. You know what spec is? Do you know what type is? All right, good. So you use types. Types are much are simpler to use than writing all those things, and doesn't require you to be consistent everywhere, just to use the same type. But it's checked by the compiler, so good. And that's documentation. That's that the compiler will tell you if you're doing things wrong, if you have types that you are not using, etc., etc. Amazing. But then you have the code spread out in multiple modules. And some modules use the same type as others because your types are tuples with 3 elements. So, and in that case, you have to share these types, right? And how do you share these types? I guess everybody knows how to share types, right? Copy and pasting. You put the same type all over again, that's fine. No? OK. Better alternative. You can use header files. You can use HRL. You put the types there. You import the HRL everywhere. And you get your users to hate you a lot because they have to add the HRL with include lib and find the path. And if they switch from Erlang MK to Rebar 3, they have to. No, man. So there is another way. You can export types. OK, you knew spec, you knew type. Do you know what spec type is? Few people. I like that. Something new for everybody. OK, so basically what you're saying is, in the same way that you are exporting functions, you can export the type. And every place in every other module can use the same types as this module, like this. OK, but the question here is, where is source module, or who is source module, right? Where do you define your types? And there are many alternatives. My proposition is that you define the types in the only module that you use them. I wrote that in a very complex way, but basically, if you define a type for games, you have a module that manages games. And the only module that knows how a game is built internally is that one. Let me show you. So I have a facade module, the module for the game in general, called Neem. And this module has a start function that creates a game, but it doesn't build the tuple. It derives the building of the game to a module called Neem game. It also doesn't build the players or the board or whatever. Everything is derived to the actual modules that know how to deal with those things. The same happens with the function cross. And you see the types, they are all fully qualified with the module names. There is that thing on the top right, Neem game T, I will show you in a second. This is the second. So you have a type, you're defining a game, right? That thing with 3 elements. So basically, the game doesn't know what the player how the player is structured internally, but they know what the player is, player type T. And the type T is opaque. And that's the last thing I will ask. Do you know what opaque is? OK, it's the same thing as a type, but the only module that is authorized to know the internal structure of that type is the module where it's defined. With that, and running dialyzer, which you should be doing all the time, no questions asked, and you get a warning if somebody else is pattern matching on the internals of game or whatever other module you have. And that goes like for the cross function is the same. You see how I'm deriving. The game knows about next and current, but it doesn't know how to cross lines, so it's derived to the other module. And the general structure is that one. You have a module representing your type. You have a type T with the definition, and it's exported and opaque. And every function either returns a type or has a type in their arguments, right? And the only functions that do this are the ones in this module. So every other module will derive their behavior to this one. And that's super fun, but why, right? The fact that you can do it doesn't mean that you have to do it. But anyway, let me go back to the problems and super quickly tell you that remember the problem with maintainability? Well, if you have to change something in the game, you know where to change it, right? It's the game module, done. Out of the question. Documentation is validated by the compiler and dialyzer, and edoc knows how to generate that. Your users are happy. They don't have to import HRL files or whatever. And it's still hard to debug, but it's a little bit easier because everywhere you get an error, you know, because the stack trace will tell you in which module the problem is, and the functions are 3-liners or something like that, so much easier. And you make dialyzer happy, documentation happy. You organize your code. You can add you can switch implementations in the same way that object-oriented people have done for ages, and you can apply common interfaces like behaviors and whatnot. And basically, you are modeling your problem domain better by explaining to whoever is reading your code that that string is not a string, that's a player, right? And you can read the code and understand much better what's going on there, which makes that code better software. Then I have a friend of mine called Erlang that's a game developer, and he's always against me, so I will present his complaints here. So of course, you have more modules and more functions, so if this space is a problem for you, all right? And then, and then you might have performance issues because you're channeling calls through different modules, et cetera, et cetera. That's, as usual, you have to benchmark. If it's a problem for you, yeah, this is not the approach for you. But if it's not, I think it's good. And the last one is you cannot use all the fancy techniques because of you don't use pattern matching, so you can not do many fancy things. On the other hand, Elixir has the same thing already, and they learned from our mistakes. So I post that if you don't trust me, trust Jose and the Elixir core team, because they're saying the same thing as I'm saying. If you want to keep reading further, you have those links. They are in the slides. And that's it.
All right. Any questions? A lot to ingest.
You mentioned maps, but then didn't talk about them?
Yeah, because in the end, maps in this context are used to represent types. So in the same example, you could eventually, once you have all code organized, you can replace the internals of game from a 3-element tuple to a map with proper naming and properties and whatnot. Nope. All right.
Let's go ahead.
One last thing. We organized Spawnfest with a friend of mine last December, and it was a blast. There were many. It was an online contest for Erlang and Elixir developers. We have many entries. It was super fun, and this year it will happen again after the Soccer World Cup. So stay tuned. It will be really interesting, and the prices are generally good. Yep.